Yeah, good evening, children. So I have received images from yeah, Leslie, Mohit, Roshni, Hariharan, Sahana, Laksha, Aragamai, Abhishek, Mritsa, Haripranav, Prenu, Bhavishya, Srivatsan has just shared. Right? Srivatsan has just shared. 1 second. Okay, Srivatsan, Niveda, yeah, Niveda. Yeah, and Swati has just shared. Okay. All right. So I think some of us are not in the meeting today. Abhishek, Aragamai, Bhavishya, Blasi, Haripranav, Laksha, Mohit, Mutsa, Niveda, Prenu, Roshni, Sahana, Srivatsan, and Swati. I think, yeah, I think all of you have shared the images. That's great. Very good. Some of us are not in the meeting today. Okay, so all those present in the meeting have shared the images. That's great, children. Thank you so much for the response. Aniruddhan, did I see in the meeting? Aniruddhan is there. Aniruddhan is not there. All right. All right, children. So now let's discuss the answers. See the first one. The paint in a certain container is sufficient to paint an area equal to 5.25 meters square. The volume of paint is not given to you, but that volume of paint, whatever is the volume of paint in the container, it is sufficient to paint an area equal to 5.25 meters square. 5.25 meters square is not the volume of the paint. It's the area which can be painted using that volume of paint. How many cuboidal blocks each can be painted out of this container? Now the question is, should we find the volume of the cuboidal, volume or area? That's what we have to decide. How many cuboidal blocks? You have to find the number of cuboidal blocks, but in the calculation, should we find the area or volume? Now, where will the cuboidal blocks be painted? On the surface. The surface of the cuboidal blocks have to be painted. Surface meaning surface area you have to find. Now, the total surface area of one cuboidal block is given by the formula 2 into LB plus BH plus LH. This is the TSA of one cuboidal block. This is the total surface area of one cuboidal block. Why are we finding the total surface area? It is the area which has to be painted. It's the area that has to be painted. And this is the area of one cuboidal block. Like this, how many can be painted? We don't know. So let the number of cuboidal blocks that can be painted be n. Let the number of cuboidal blocks that can be painted be n. Now you should also mind the units. The dimensions of the cuboidal block is in centimeter, but the area here is given in meter square. So we need to convert that area which is given in meter square to centimeter square. So 5.25 meters square. How do you convert that to centimeter square? Meter to centimeter, we'll have to multiply by 100. To convert meter to centimeter, we multiply by 100. Millimeter, centimeter, decimeter, meter. To convert meter to centimeter. So you're converting upwards, so you'll have to multiply and multiply by 100. And if you have to convert meter square to centimeter square, Do the same thing 2 times. So 5.25, when you multiply it by 100, you're converting meter to centimeter. When you multiply this by 100 again, you're converting meter square to centimeter square. So you have paint to paint this much area. You have paint to paint this much area. So the question is, how many cuboidal blocks can be painted using this much of paint? So the equation is, let the number of cuboidal blocks that can be painted be n. N into the TSA of one block. N into TSA of one block is equal to this area. Is equal to this area of 5.25 meters square. Or you can also write like this, number of block. Number is always, whenever you have to find a number, it is always area by area, some area by some area, or it will be volume by volume. Whenever you find area by area or volume by volume, you can find a number, meaning number of, in this case, cuboidal blocks. Whenever you have to find the number, it is area by area or volume by volume. It's area by area or volume by volume. When it is area by area, that the greater area will come in the numerator. The smaller area will come in the denominator. See, in this case, the number of cuboidal blocks is equal to area by area. Now, which area in the numerator, which area in the denominator? The bigger area should be in the numerator. The bigger area is the total amount of paint that is available. So that 5.25 meters square, this one will come in the numerator. In the denominator, the smaller area will come. That is the area of each cuboidal block. The area of each cuboidal block. That's the smaller area. That will come in the denominator. So you can also do directly like this. The number of cuboidal blocks. Number of cuboidal blocks is equal to 5.25 meters square. This area by the area of one block. The area of one block, that is 2 into LB plus BH plus LH. Of course, this one is in centimeters, so you'll have to convert this to centimeter square. So, see here. So let the number of blocks be n. The TSA of one block into the number of blocks is equal to the total area painted. The TSA of one block into the number of blocks is equal to the total area painted. So you can see this. So the number of blocks is equal to total area divided by this. If you transpose, that's what you will get. If you transpose, a number of blocks is equal to total area painted divided by this one, TSA of one block, divided by TSA of one block. See, number of blocks is equal to total area painted. And if you bring this to the other side, it will come for division. So divided by TSA of one block. That's what I told you. So the TSA of one block is 2 of LB plus BH plus LH into number of blocks is n is equal to 5.25 meters square. Now substitute the values into n is equal to, I told you all these are in centimeter, so you need to convert this also to centimeter square. Then find the products. Find the products. Into n is equal to 5250 centimeter square. Then find the sum. And n is equal to 52500 divided by, this one comes to the other side for division, divided by 2 into 875. On simplifying, you get 30. So the number of blocks is equal to 30. So I told you whenever you have to find a number, it is area divided by area. The greater area in the numerator, the smaller area in the denominator. It will be area by area or volume by volume. The bigger volume divided by the smaller volume. So here also it's the same thing. See, a number of blocks is equal to the total area that is painted divided by the area of one block. That's about the first one. A cubical box has edge 12 centimeters. Another cuboidal box is 15 centimeters by 12 centimeters by 10 centimeters. Compare the TSA and the CSA of both. So cubical box formula TSA is 6A square. Cuboidal box TSA formula 2 of LB plus BH plus LH. Both are in centimeters. This one is in centimeter. This one is also in centimeter. I think by mistake I put meter square here, children. There's a mistake. I'll correct it. It's EN. This is centimeter only, children. Centimeter squared. So you'll have to compare. So you can see that this one is more. The TSA of the cuboidal box is more. So compare. So TSA of the cuboidal box is 36 centimeters square, more than the cubical box. You should also compare their curved surface areas. CSA formula for cubical box is 4A square. For cuboidal box is 2H into L plus B. So be careful when you substitute. Where you can go wrong here is in this place. 2H into L plus B. So 2 into H you should put. That is 10. By mistake, if you put 15, you will not get the correct answer. 2H into L plus B. 2 into H. H is 10. H is 10. Into L plus B. 15 plus 12. This is length. This is breadth. This is height. So substitute carefully. And we get 540. So here you see that the curved surface area of the cubical box is more than the cuboidal box. The CSA of the cubical box is more than the cuboidal box, while the TSA of the cuboidal box is more than the cubical box. In TSA, cuboidal box has more area. In CSA, the cubical box has more area.
Ma'am?
Yeah.
Ma'am, you have written meter. It is centimeter square, ma'am.
Yeah, I told you, no? I told you, yes. I did correct that.
Okay.
Didn't I say? Yeah, I did mention that.
Okay.
Yeah, please disable your mic. Just a second, children. Yeah, children. In the next question, it is required to make a closed cylindrical tank of height 2.4 centimeters and base diameter 280 centimeters from a metal sheet. I think there's a lot of printing mistakes. See, I've written centimeter here and meter here, no? I'll change this to meter. I'm sorry. I've written meter, centimeter here and meter down here, children. Very sorry. I'll change it to meter only. Because I've taken meter here. Radius 1.4 meters. What have I written? Second. Oh, I've converted to, okay. Okay, this one should be meter, 2.4 meters. Yeah, and this one is centimeter only. Okay. This is height is, please do the correction in your classwork. Height is 2.4 meters, children. Please open your notebook. Correct this unit. 2.4 meter. And diameter is 280 centimeters. Please do this correction. Height is 2.4 meters. Base diameter is 280 centimeter. This unit is correct. Okay. So how many square meters? How many square meters meaning this is the unit. Square meters meaning meter square. This is the unit. How many square meters of sheet are required if 12% of the metal sheet used is wasted in cutting and overlaps? Okay. So the height is given to be 2.4 meters and the diameter is 280 centimeters, which means the radius is 140 centimeters or 1.4 meters. Since we have to find the area in meter square, we're trying to have all the values in meters. Height is 2.4 meters. Okay. Diameter is 280 centimeters. So radius is 140 centimeters. Convert this to meter. So you'll have to divide by 100. So it's 1.4 meter. That's what you see here, 1.4 meter. Now you have to build a closed cylindrical tank. So you have to find the total surface area. It's a closed cylindrical tank. So you'll have to find the total surface area. So the total area of metal sheet in the closed cylindrical tank will be 2 pi r into r plus h. The tank is made of metal sheet. The metal sheet will be used all over because it's a closed tank everywhere. The curved surface area, the base and the top, everything is made of this metal sheet. So you'll have to find the TSA using the formula 2 pi r into r plus h. Substitute the values and when you work, you get 33.4 meters square. 33.4 meters square. 33.44 meters square. Now, further, so actually it is, you need how much, metal sheet you need? 33.44 meters square. So much metal sheet you need. But what is given in the question? 12% of the metal sheet used is wasted in cutting and overlaps. That means supposing you buy 33.44 meters square of metal sheet from the market, 12% will be wasted. So then you cannot build the tank with these values given, this radius and this height. It will be a smaller tank. The total surface area of the metal sheet in your tank should be 33.44 meters square. If you buy exactly this much, there should be no wastage. If you buy exactly this much, if there is no wastage, it will be sufficient to build this closed tank of radius 1.4 meters and height 2.4 meters. But here there is wastage. That means you must buy a little more. Since there is wastage here, you should buy a little more. Only then, after the wastage, you will have 33.44 meters square of metal sheet to build this closed tank of the given radius and the given height. So let the area of metal sheet, see, it's similar to, like when you have to make a model using a chart paper. Okay, supposing you'll have to make a model using chart paper, and if you buy 4 chart papers, if you buy 4 chart papers, okay, if you buy 4 chart papers and you make the model, all the area in this 4 chart papers will not be there in the model, because when you cut and all that, so much of wastage will be there in the cutting, and in the making of the project, in the making of the model, so much of chart paper is wasted, will be wasted. And finally, when your model is ready, maybe the area of the chart paper in the model will be equal to 3 chart papers. Will be equal to 3 chart papers. Almost 1 chart paper area will be wasted in cutting and all that. I'm just saying roughly to give you an idea. So whenever you buy material to make some model, all that material you cannot put it in the model. There will be wastage. In the same way here also, if you buy exactly 33.44 meters square, you cannot make this tank of radius 1.4 meters and height 2.4 meters, because there's wastage while building the tank. So you have to buy a little more. So you'll have to keep that extra sheet for the wastage, extra area for the wastage. So let the total, so how much you're buying, it will be more than 33.44. How much you will buy then? There will be wastage. So you will buy a little more. So you don't know how much, in this case, we don't know how much we're buying. So let the total area of metal sheet required to make the tank be X meter square. Now you're buying X from the market. How much is wasted? 12% of X is wasted. 12% of the metal sheet used is wasted. How much ever you buy, on that 12% is wasted. You're buying X meter square from the market. 12% of X, 12% of how much ever you have bought from the market is wasted. So you're buying X meter square of, that steel metal sheet from the market. And in the process of building the tank, 12% of X is wasted. Because see here, 12% of the metal sheet used. How much did you use? How much you used, meaning how much you bought. How much you will be using. Whatever you buy from the market, you're using. Whatever you brought from the market, that much you'll be using. So 12% of the metal sheet used. You bought X meter square. So 12% of X is wasted. So X, so you purchased X. 12% of X is wasted. So minus, wastage should be subtracted. So you purchased X minus the wastage. Now that remaining thing, that remaining metal sheet, where is it now? It is in the TSA of the tank. Like you buy 4 chart papers, minus 1. 1 is wasted. So the remaining 3, where is the area of the 3 chart papers? It is all in the model. In whatever model you've made. You bought or you used 4 chart papers to make the model. You used 4 chart papers to make the model. In the process of making the model, about 1 chart paper area is wasted. So how much is used? I'm sorry, how much is now actually in the model? The area equal to 3 chart papers is in the model. In the same way, you purchased X meter square of metal sheet from the market. Wastage should always be subtracted. So minus 12% of X is wasted. So subtract. Now whatever is remaining, whatever remains, where is it? It is in the total surface area of the tank. So is equal to the TSA of the tank. So X minus 12% means 12 by 100. 12% means 12 by 100. Off means into X. 12% is 12 by 100. Off means into X. So that's nothing but 12X by 100. That is nothing but 12X by 100. So X minus 12X by 100 is equal to 33.44. Now, when you work this, you get 38. So the area of the metal sheet required, or the amount of metal sheet which you have to buy from the market, is 38 meters square. If you buy 38 meters square, after the wastage, 33.44 meters square will be in the cylindrical tank. So that way you'll be able to build the tank of this given height and this given radius. Is that fine, children? First, you have to find the total surface area because it's a closed tank. You'll have to find the TSA of the tank. How many square meters, meaning this is the unit. How many meters square of sheet? That means what area of sheet. So find the TSA of the tank. And since there is wastage, you should buy a little more. So let it be X. X minus the wastage, 12% of X, is equal to the TSA of the tank because the remaining material is now in the TSA, the total surface area of the tank. So on working this, you will be able to find the value of X. So 38 meters square of metal sheet is what you should be purchasing from the market. This unit alone, I said, please correct, it's meter. Next one. Find the curved surface area of a closed cylindrical petrol storage tank. Find the curved surface area of a, see, it's a closed tank, but they want you to find only the CSA. So find the CSA. Find the curved surface area of a closed cylindrical petrol storage tank of diameter 11.2 meters and height 10 meters. Find how much steel was actually used if 10% of the steel actually used was wasted in making the tank. So similar situation, very similar to the earlier one. This one. So here they did not ask you to find anything. They did not ask you to find the CSA or TSA. But we found the TSA because we know when it's a closed tank, we have to find the TSA. Because that is the total area of sheet required to make the tank. But here in this question, they want you to find the CSA. So we need to, work as per the instruction. Find the CSA. So radius is half of this, 5.6, and height is 10 meters. Find the CSA, 2 pi RH is the formula, substitute the values, calculate carefully. You can write 5.6 can be written as 56 by 10 in the next step. See, 7 ones are 7, 0.8 times. Calculation alone you cannot see here. You have to do that. When I say calculation, I'm talking about simplification. Okay. Or you can write 5.6 as 56 by 10 also. Okay, so find the CSA of the tank. Now that CSA we found because they wanted us to find. Now we will find the TSA of the tank. That we will find by ourselves because we know it is a closed tank. It's a closed tank. So to work this answer, we need the total surface area. We found the CSA because we have been asked to find. And the total surface area we find because we need this to work the answer. Okay. So find the CSA, then find the TSA, 2 pi r into r plus h. Now, as we did earlier, this is exactly what you need to build the tank. This much steel you need exactly to build the tank. But if you buy this exactly, you will not be able to make the tank of the given radius and given height. You will be able to make a tank, but you cannot make the tank of the given radius and given height. It will be smaller than that. Why? Because some amount of steel will be wasted while making the tank. This is the exact area. This is the exact area of the steel you need to build the tank of this radius. What radius? 5.6 meters radius and 10 meters height. If you want to build a tank, if you want to build a closed tank of radius 5.6 meters and height 10 meters, then you need exactly 549.12 meters square of steel. You need exactly so much of steel. But if you buy exactly so much, since there is wastage in the building process, you will not be able to make, you will be able to make a closed cylindrical tank, but not of this radius and this height. It will be smaller than that. Because if you buy exactly this, there is some wastage also. So you will have to keep that margin for the wastage. So you should buy a little more. You should buy a little more so that even after the wastage, you have this area of steel remaining, with the help of which you can build the tank of this given radius and this given height. Okay. So as I told you, CSA we find because they've asked us to find. TSA we have to work because it's a closed tank. So we need TSA for further calculation. Now, as we did in the earlier one, let the area of steel actually used. Actually used means actually purchased from the market. Actually used means actually purchased from the market. See, if supposing that same chart paper, you bought 4, wasted 1, and 3 is in the model. You bought 4, 1 wasted. Now 3, the area of 3 chart paper is in the model. Now if somebody asks you, how many chart papers you used to make the model? How many chart papers did you use to make the model? Will you say 3 or 4? You will say 4. How much did you use? You used 4. I used 4 chart papers to make the model. 1 was wasted and the area of 3 papers is now in the model. So when somebody asks you the question, how many chart papers did you use? You will say 4, not 3. In the same way, how much of steel was actually used is how much you purchased from the market. So let the steel actually used to make the tank, that is actually purchased from the market, be X meters square. So you purchased X, 10% of X is wasted. So what you purchase minus the wastage, that remaining steel, where is it? It is in the TSA of the tank. You bought X, you wasted 10% of X. Now that remaining, where is it? It is in the body of the tank. It is in the body of the tank. And what is that body of the tank? It's a total surface area of the tank. So now work this. X minus 10% means 10 by 100, of meaning into X. So 10X by 100. Okay, so X minus 10X by 100 is equal to the TSA, which we have already found. We've already found. Put that answer here. Now this calculation you can do however you want, children. See, you can cancel the 0 and 0 and then take the LCM. I have directly taken the LCM. So I got 90x LCM, children, this is. LCM, like x minus 10x by 100. What's the LCM? 100 is the LCM. So 100x. 100x minus 10x. 549.12, like this. Or you can cancel also. You can cancel the 0 and 0. You'll get 9x by 10. So simplification you should know. So 0 gets cancelled and 9 by 10 goes to the other side as 10 by 9. And on simplifying, you get 610.13. So you should purchase so much of steel from the market so that when 10% of this one is wasted, you are left with this one, which is exactly needed to make the cylinder, the closed cylindrical tank of this diameter and this height. Very important question, children. See whether you're going to get this in the exam or not. The knowledge about how to work this is important, is what I'm trying to say. The knowledge involved in handling this question, that is important, is what I'm trying to say. Okay, next one. Find the cost of painting the curved surface area of a conical tomb. Height and diameter is given to you. Conical. And you'll have to find the cost of painting only the curved surface area. So when it comes to a cone, for volume, you need the perpendicular height. For area, you need the slant height. When it comes to the cone, when you're finding volume, you need perpendicular height. Area, you need slant height. So you're given the height h 35 meters and diameter or radius is equal to 84 meters. So using this, you should find the slant height. Slant height is equal to square root of h square plus r square. So work this and find the value of L. Then find the curved surface area, pi r L. Find the curved surface area. The area will be in meter square because height is in meter, radius is in meter. So you'll get the area in meter square. And the rate of painting is rupees 855 for 100 meters square. For 100 meters square, it's rupees 855 for 100 meters square. So for 1 meter square, how much? 855 by 100. Rupees 855 by 100 will be the rate for 1 meter square. What is given is rupees 855 is the rate for 100 meter square. For 100 meter square, it is 855. For 1 meter square, it will be 855 by 100 for 1 meter square. So this is the rate for 1 meter square. This is the rate for 1 meter square. So after finding pi RL, multiply this area by this rate to get the total cost. See, in this question, it's about a conical tomb. You need to find the cost of painting the curved surface area. Whenever you have to find the curved surface area or the total surface area of a conical, of anything conical, you need this. For area, you need slant height. For volume, the formula is 1 by 3 pi r square h. You need perpendicular height. So first step is to find the slant height using the relation root of h square plus r square. This is the first step. After finding L, find pi RL, the curved surface area. Find pi RL. That answer will be in meter square. Because height is in meter, radius is also in meter. So you'll get in meter square. Now you should find the cost. This is the area. Pi RL is the area. So the cost will be whatever is the area into the rate. Cost is whatever is the area into the rate. When you're multiplying with the rate, it is 855 rupees for 100 meter square. So divide by 100 to get for 1 meter square. So first find the slant height, then find pi RL. The cost of painting is equal to the area into the rate. Area into rate. Why 855 by 100 is because it is 855 rupees for 100 meter square. So for 1 meter square, it will be 855 by 100. So whenever you're given some value, like here you're given that CSA is 3168. So CSA is 3168. The curved surface area of a cone is 3168. CSA is given by the formula pi RL is equal to 3168. Pi is 22 by 7. Now diameter and slant height. So diameter is 8x. So slant height will be 7x. So what will be the radius? Radius will be 4x. Diameter and slant height are in the ratio 8:7. So if the diameter is 8x, the slant height is 7x. Then what's the radius? 8x by 2, 4x. So 22 by 7. See, whenever you given volume or CSA, you should work with that one. Write that. CSA is equal to 3168. CSA is pi RL. Pi RL is equal to 3168. 22 by 7 into radius 4x into slant height 7x is equal to 3168. When you work this, you'll get x square is equal to something and x is equal to something. Because x into x is x square. So x square is equal to something and x is equal to something. Once you find x, you can find 4x and 7x, radius and slant height. Okay, so you can find the 7 into x is the slant height. Then find the radius 4 into x. Now using L and R, you should find the perpendicular height h. H is equal to root of L square minus R square. You can see here, diameter is 8x, so radius is 4x meter. This is the unit. Meter is a unit. 7x meters, unit that is. 7x meter, 4x meters, 8x meters. CSA is given, so pi RL is 3168. 22 by 7 into 4x into 7x is equal to 3168. X into x is x square. And the 7 and 7 will get cancelled. X into x is x square. 7 and 7 will get cancelled. So x square is equal to 3168 divided by this 22 and 4 will go down for division. So x is equal to 6. Once you find x, you can find this one and then use a relationship to find h. Okay, the next one. The radius of a spherical balloon. Online students, use the emoji, raise your hand. Laksha, Haripranav, Anirudhan, Mritsa, Bhavishya, Blessy, Aragamai, Srivatsan, Prenu, Swati, Mohit, Niveda, Sahana, Abhishek, Roshni. The radius of a spherical balloon, spherical, sphere. The radius of a spherical balloon increases from 10 centimeters to 15 centimeters as air is being pumped into it. So it's a balloon. When air is pumped into it, the radius increases from 10 to 15. The radius is actually 10 centimeters. Now, since more air is being pumped into it, the radius increases to 15. Find the ratio of the volumes and surface areas of the balloons in the two cases. Find the ratio. You don't have to find the volume separately. There are two cases, no? One when the radius is 10 centimeters and the other when the radius is 15 centimeters. You don't have to find the answer separately. Directly find the ratio. I told you in the last class. Whenever it is ratio, directly find the ratio. You don't have to find the volume or surface area separately. Directly find the ratio. So you should find the ratio of their volumes. So I've called it the original volume and the new volume. Original volume is with radius 10 centimeters. New volume is a volume with radius 15 centimeters. And in both the cases, it's a sphere. In both the cases, it's a sphere. Initial radius 10 centimeters. New radius 15 centimeters. So what's the ratio of the volumes? Original volume by new volume. That's the ratio of the volumes. Original volume when the radius is 10 centimeters. New volume when the radius is 15 centimeters. So 4 by 3 pi small r cube by 4 by 3 pi capital R cube. 4 by 3 pi gets cancelled in the numerator and denominator. So it's nothing but r cube by r cube. 4 by 3 pi gets cancelled. So we have r cubed by r cube. Now substitute the values. Small r is 10, capital R is 15. So 10 cubed by 15 cubed is 10 by 15 the whole cube. And you can cancel inside. It's 2s are 3s are 5 2s are 5 3s are. So it's 2 by 3 the whole cube or 8 by 27. Yeah, sorry, children, I had to. Yeah. Yeah, I don't know where I stopped. Yes. Now, next again, like this, we'll have to find the ratio of their surface areas. The ratio of their surface areas. So original surface area by the new surface area. And for a sphere, surface area formula is 4 pi r square. So 4 pi small r square by 4 pi capital R square. 4 pi and 4 pi gets cancelled. So small r square by capital R square. Small r is 10, capital R is 15. 10 square by 15 square. 10 by 15 the whole square. Cancel. 2s are 3s are. 2 by 3 is a whole square, which is 4 by 9. 2 by 3 into 2 by 3, which is 4 by 9. So the ratio of their volumes is 8:27, and the ratio of their surface areas is 4:9. I've been stressing, find the ratio directly like this. Don't find original volume 4 by 3 pi r cube. Don't find this separately. Find the ratio straight away like this. So it's easy because 4 by 3 pi, 4 by 3 pi will get cancelled. A hemispherical bowl is made of steel, 0.5 centimeters thick. The inner radius is 10 centimeters. Find the cost of painting the bowl all over at the rate of 56 paise per centimeter square. So where all is the bowl painted? The inner CSA will be painted. The inner CSA, this one. This is the inner CSA. This will be painted. The bowl is thick. The bowl is thick. So the outer surface area, this one. This is the outer surface area. This will be painted. The outer surface area is painted. And then on the top, on the top you see a ring. On the top you'll see a circular ring like this. On the top you'll find the circular ring. Circular ring, not oval like this. A circular ring you'll find here because the wall is thick, no? The wall is thick, so you'll find a flat portion here. A circular flat portion on the top. That also has to be painted because all over it's painted. So the area that is to be painted is the inner CSA, the inner curved surface area of the bowl, the outer curved surface area of the bowl, plus the area of the circular ring on the top. These are the three different regions that have to be painted. The other day we took the example of half of a coconut to understand this. So just imagine the coconut. If something similar to that half a coconut is made of metal, just keep the picture of half of a coconut in your mind, half of a coconut, half of a full spherical coconut. So it's a hemispherical bowl kind of thing. So where all will you paint the inner CSA, the outer CSA, and the ring on the top? Three surfaces. So the inner CSA's CSA formula is 2 pi r square for a hemisphere. For a hemisphere, CSA formula is 2 pi r square. So 2 pi small r square for inner CSA, 2 pi capital R square for outer CSA. Then the area of the ring on the top is pi capital R square minus small r square. Now we have given the internal radius 10 centimeters. Thickness is 0.5. So the capital R will be small r plus W. Inner radius plus the thickness. Inner radius 10 plus the thickness 0.5. 10.5 is the outer radius. So the total area of the bowl to be painted is equal to the inner CSA, 2 pi small r square, outer CSA, 2 pi capital R square. Because for CSA of a bowl, it is 2 pi r square, hemisphere. Ring on the top is pi r square minus r square. Now, when you substitute the values, don't substitute for pi. Don't use 22 by 7. So see, I put the values. Small r is 10. Capital R is 10.5. 10.5 square, 10 square. Don't use the value of pi, children. So 10 square is 100. 100 into 2 is 200 pi. 10 square is 100. 100 into 2 is 200. 200 pi. 10.5 square. Please find that into 2. 10.5 square. 10.5 into 10.5. That answer into 2. You get 220.5. Pi as it is. And here also. This one square minus this one square, pi. Add everything. Add all these. So you get pi like x. If all this were x, you would add all this, right? In the same way. Add. And whatever is a number, pi, centimeter square. This is the area of the bowl to be painted. Now the cost of painting is equal to area into rate. So this is the area. This is the area into the rate. 56 paise. See, the rate is given in centimeter square only. 56 paise for 1 centimeter square. The rate is 56 paise per centimeter square, meaning for 1 centimeter square. 56 paise for 1 centimeter square. So for 1 centimeter square, 56 paise. For so many centimeters square, how many paise? So it will be this area into 56. Don't forget the pi, children. Here you can see the pi. So whatever is this one here, 430.75 pi into 56 paise. So 430.75 into pi is 20. This pi is 22/7 into 56 paise is how many rupees? 0.56. $56 paise. See, if you don't convert this paise to rupees, the answer which you get will be in paise. Then the final answer you'll have to convert it to rupees. It's not that you should convert it here itself. Here you can have this 56 paise. So you'll get the answer in paise. Then you'll have to convert that answer which is in paise to rupees. So the wall is thick and the inner radius is given. So inner radius is small r, 10. Thickness is W, 0.5. So outer radius will be 10 plus 0.5, just 10.5. So the total area of the bowl is hemispherical bowl is inner CSA, outer CSA, area of the ring. So the cost of painting will be the total area to be painted. I told you don't use the value of pi. Till here you can just have it as it is. Here when you substitute, use pi is 22/7. 56 paise is 56 by 100 rupees or 0.56. I thought I'll finish it, but it's already 15 minutes past the time, so I'll not take any more time of yours. We'll finish the remaining 3 sums in the next class. 3, right? 1, 2, 3, 4. Yeah, 4. Okay, so we'll understand the remaining 4 sums in the next class, children. All right, children. So that's it for today's session. Thank you so much. You may leave the call. Good night, children.
Thank you, ma'am.
Thank you,
Thank you,
children.
ma'am.
Thank you, children. Good night.
Thank you, ma'am.
Good night. Thank you.